when people ask, "Oh, a language is built for games," that doesn't really mean anything. Actually, to me, it's quite funny when it's only for games, and I'm thinking that games are a lot broader than you think. Then in that regard, so for me in Odin, I was very pragmatic. I went, I don't want operator overloading. That is a hell I do not want to get into. I've seen so much bad stuff. To be very clear, my actual background is not programming necessarily. I'm a physicist. I used to be a quantum physicist before doing all this.
Hello everyone, welcome to the Game Engineering Podcast. This time I'm joined by the creator of Odin programming language, Ginger Bill. He is incredibly knowledgeable, pushes for robust but simple software, and is doing something revolutionary with Odin language. We discuss Odin goals and features, Bill's work at JangaFX, and the state of software today. Join us for an inspiring discussion with a lovely British accent. Let's discuss Odin, and I think we should start with some overview of the language, but also for the most details probably we can relay people to some, for example, Odin tutorial, great resource.
Yes.
And now Odin book, we'll get into that later.
Yes.
Let's start with an overview. Why Odin? What is Odin? Stuff like that.
Absolutely, sure. That sounds okay to me.
Let's do it then. What is Odin language?
Odin is a C alternative for modern systems programming, pretty much. That's what I was designing it for. I created the language about 8.5 years ago, back in 2016, out of my frustration from using C in a certain sense. So I kind of wanted a general purpose language that I was trying to, how do I put this? Back in 2016, early days, I was trying to create a C alternative. In fact, literally what I was trying to do was C with some augmentation on top. So literally, the first two things I did was add slices and defer.
Okay.
They were the things that the first statement, they were the first two things I added. Then I realized, okay, let's go and try and fix the other problems to see. And then very, very, let's say quickly, over a couple past few months, I went, oh, I can't fix C. It's fundamentally broken. As soon as I try and fix it, especially its type system, I'm not even talking about the syntax, just the type system. Yeah, you realize you need another language. So I thought, okay, I'll try and make my own language, as I did. And then here I am now, 8.5 years later, using it as part of my full-time job, and many people are as well, which is kind of surreal. Is the best way of putting it.
It's not a common history. If somebody says, "Oh, I'm gonna create a new language because I'm frustrated," it's usually like, okay, 3 months in, you forgot about the idea.
Yeah.
So good luck, a good job on the persistence and perseverance.
Yeah, well, maybe it was just insanity as well, not just hard work, but yes.
So C, Odin is a C alternative for modern systems. What would be the features of C programming languages that you wanted to get rid of, and what do you want it to fix?
Well, there was quite a bunch of things actually. One of the very first things was I wanted to kind of like a proper array type in C. C doesn't really have, how do I put this? C does have arrays, but they automatically get demoted to pointers. So then when you're indexing them, it's just using the pointer arithmetic. So the indexing operator is, many people may know this, as literally just sugar. So instead of just doing like an array indexed by I, you can do I or indexed by the array.
Yeah.
Because it's sugar for pointer arithmetic at the end of the day. Now, that may say like, oh, it's that much of a problem. Well, the thing is, I wanted a proper array type. Like I wanted to know what the length of the array I was passing around without having to pass an extra variable, and also have bounds checking. One of the main kind of things that I want was the bounds checking. And it was kind of annoying that I tried to emulate a lot. Most people, so why don't you try use C++? Well, that's the first thing I do when I use C++. I create an array type with a bit of operator overloading that's got bounds checking in it. Doesn't mean I actually like C++ though. Like C++ is a hell of a lot bigger language than just C with classes, as some people think, or C with all templates or anything like that. Like I prefer C generally because it is a smaller language. It has a smaller subset, but it also doesn't give you the opportunity to do different styles of programming in a weird way, which sounds like, oh, don't you want the freedom? The answer is not really, actually. I kind of want I kind of want something that is, this is how it works, and that's all I have to deal with. And I know that is great. Like this C is very procedural, and I can just deal with that procedural paradigm rather than trying like, oh, maybe do the object-oriented, shall I go the template, shall I go full on generic, blah, 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 what it is. And it always goes a little bit there.
Yeah. So over time, probably you've added more and more features to Odin, right? And you kind
Yes.
of try to, I would assume, like crystallize the version. What makes Odin better? Like, what would be the features that you want to have this in Odin? Can you tell me what was the process of like deriving the Odin essence for the language?
For the essence of the language, when I was first designing it, I would say I got the essence done within about 3 months.
Okay.
Because I kind of knew what I wanted from the language, and Odin's not the first language I've ever made either.
Okay.
It's just the first language that kind of got big um, in that kind of regard. So the question was like, what was the essence? Well, I went, okay, I want something that still feels like C, but also have like I learned lessons of like the past of like Pascal as well, because I'm a big Pascal fan, especially from Niklaus Viet or Nicholas Worth. I'm never sure how to pronounce his name, but I don't think he minded. He always used to make a joke of it. But it was one of those which, like, I knew that kind of wanted C feel, but also try and fix a lot of the type system problems as well. Like a good example of this would be I didn't want any of the random implicit conversions or the integer widening or like that just causes a bunch of bugs. Yes, you can imply all the warnings in the compiler, but that still doesn't fix the fundamental semantics which are broken. So it's kind of like, yes, you put in more warnings, but it doesn't help. But then, like, that's the thing is the essence still had to feel like a C language. And I wasn't trying to be big ideas, anything like this. Just C, but was in just enjoyable. Like, get rid of the things where if you've programmed in for a C a long time, you forget actually all of the tricks you're actually doing to make things work. There's a hell of a lot of things you've probably just like, oh, that's just how you do things. And it's like, you don't have to do it that way. And then as soon as you step back, you go, oh yeah, I don't have to do that, do I? But you just think it is the way because that's how it's always done to a certain extent. And but there's like other languages have done other things. So it's like, well, take some of the ideas that have been proven in other languages and just do that.
How much time have you spent in C beforehand?
In C beforehand, over a decade.
Yeah, it feels like you have scars from C, and
Yes, yes, it is kind of
okay.
that thing.
So and now Odin has quite a few cool features. Can you
Yes.
do an outline of a couple of them just to like excite people?
To excite people, this is the problem: is I'm always the worst marketer for my own language. Because to me, I'm like, to put it bluntly, I don't think in features, right? I usually think in like, okay, I've had this problem. Okay, what are the constructs, concepts, and stuff in general that needs to be fixed by this? Sometimes it's just done by the core library features, but sometimes it is the features. There are some very interesting things in the language, like sometimes, for instance, how do I put this? We have custom allocators built into the language itself. So these can be used such as like arenas, pools, stacks, many things like this. We have this implicit context system, which is mainly there for overriding third-party code, which most people always get misunderstood what this is for, but it's literally intercepting third-party code so you can modify its allocations or its logging or general thread data, or even if you've got like a sorting function that doesn't have a callback, like some user data, well, you can use the context to override that. That's I might say that's such a
So
minor thing, but it's like a
just to
really useful thing.
just to make sure that I get that and people who
Please
listen
do.
also get that. So
Yeah.
you can override the context. So the idea is that I'm calling a function that comes from a library, and the
Yes.
library would normally use an allocator of their choice,
Yes.
but I can override the allocator, and now the function I'm calling will allocate using my allocator. I
Correct.
overrode. This is super cool. This is
Yeah,
super
and it's mainly because from my hypothesis, most people don't use custom allocators. Again, when I'm at work, most people don't use custom allocators. They don't need to. So if you make that assumption that most people aren't doing that, well, by default, if you can have some way to override that, that helps a lot.
Yeah, yeah, this is super cool. By the way, just for the sake of completeness, why would you use custom allocators? In what scenarios this would be useful?
So custom allocators are just different ways for memory allocation strategies, right? The naive way of thinking about memory allocations, most people get taught that there's the stack and the heap. And the thing is that's kind of never been true in a weird sense. Like, okay, let's say literally we're going to talk about the 70s, right? Back in the 70s and 80s. Back then you had just a normal one single memory space. It was unprotected and all that lot. Sometimes they had virtual memory, but like virtual memories from the 60s, but not getting to this. Let's say you got one thing, and then you've got the stack. They say, oh, it starts here, the stack goes backwards, and then the heap goes forwards, and they all start from that point. And they view it that way, like, oh, one side's the stack, one side's the heap. Well, modern computers use virtual memory. The stack is pre-allocated per thread, per application, right? And it can be anywhere. The heap doesn't really exist. It's just the rest of the single virtual space of memory. So when people think of the heap, they're talking about something like malloc, which is a heap-like data structure. So you can start allocating things and you'll free these things, and it's just a bunch of free lists, like linked lists pointing to where the free objects are, so then you can allocate more in those sections, allocating from that virtual memory. But the thing is, that approach there with the free list, because it's completely out of order, random, it can be kind of quite slow. It can also have massive fragmentation issues as well, depending on how much memory you've got on your system, or in just general, like it's when it's searching for the next allocation slot. So this can actually make things harder just to deal with in general, because things can go slower. But it's not just about performance. It's also just about thinking about lifetimes as well. Because when you're doing malloc things, you're thinking about on a let's say per value, per object basis when you're allocating, rather than thinking in groups, right? And when you get to more advanced into programming, you start thinking in group allocations rather than grouped lifetimes, rather than individual values. Because when you're doing allocating and freeing individual values, it's an absolute pain to deal with. It will slow things down because you've got to do that. But also it's kind of it's not the only way you can do allocations, because again, most people think it's just malloc and free. The other ones would be, the first one I always introduce is arena. An arena is just literally a big set, like linear set of memory to a certain extent, and then you just keep incrementing the pointer for the next allocation. And then when you're done with that, you just free the entire arena or just reset it, and then you're done.
Yeah.
That is the arena. And that means you've now got memory that's mostly contiguous. It's you've got no fragmentation going on, and it's stupidly fast because you're just incrementing a pointer. So you've got all these different benefits. But again, all of those allocations together are a single lifetime, is what they are. So you're now treating things thinking of like, oh, this is memory level allocations. Yeah, and you're thinking in terms of lifetimes now of those allocations. You go, oh, they're all grouped together. Let's just put them all into arena. Now, there are other allocators out there, obviously, like I talked about, like a free list or a pool or a stack and such. But most of the time, if you're using custom allocators, it's usually your first thing you're going to use is most likely an arena. And then maybe a pool, where a pool is like fixed block. Each allocation must be the same size, while an arena allows for variable size.
Yeah, I asked a similar question. Guy Davidson, man who worked on Total War games, and he's a member of C++ standard, by the way. And I asked him, like, what would be the one tip you would tell people regarding the memory management? And he was like, think about lifetimes, right? Like, you want to group things with lifetimes. If you open UI, you allocate the memory for all the things you're showing, and then you want to deallocate them at the same time. So like, there's no single objects, right? And this is, by the way, this is super interesting. Even for people, let's say my daily life, I'm coding things with high-level languages, often garbage collected. Still, understanding how memory works and what the things I'm doing, what will cause a downward, it's so interesting and then rewarding to understand that, and to learn things like virtual memory, how modern operating systems are mapping the virtual memory to the physical memory, like what actually happens under the hood. It's so helpful. It like reveals what happens inside, makes it more understandable. It's so much better, cooler to program in this mindset than like, oh, things happen. I don't care about them.
Yeah, like the computers aren't magical in that sense. Like you can actually understand mostly, not entirely, but mostly how those machines work, right? And if you're on an Intel machine, you just get the Intel manual of how those architectures work and just read it. There you go. You can just read it literally. But it's kind of it does get, if you understand how these things work, it's less magical. It doesn't mean you shouldn't use it. Like I use garbage collection from time to time in different languages, but it helps that I know how it works in that language as well, because then I can actually go, oh, if I do it this way, I can actually help, quote unquote, help the garbage collector out, even though that isn't necessarily the point of it. You meant not to think about it, but it's kind of like, the thing is that allocations are just another part of the problem at the end of the day. Why are you trying to not think about that one when it's like, well, you've got 100 of other things to think about as well. And but the thing is, I think most people get taught that allocations are hard, right? Because they get taught about malloc and free. And you know what? Malloc and free is a pain in the proverbial backside to deal with. But like arenas, which sound more complicated, actually make everything simpler. Like I now just have to think of, oh, which lifetime is okay, put it into there, and now I just free that arena when needed. Now sometimes I need a malloc like freeing and allocations. That's fine, but that's not the default I found. But everyone defaults to that and then thinks, oh, that's why manual memory management is hard. And it's like, that's not even manual. That's just very high up the level of the stack already with malloc and free. It's just now you've got all this extra book taking to do.
Yeah.
Why? You don't. But again, that's how it gets taught. It still is.
Yeah, unfortunately, I think. One cool thing about Odin is that it ships with vendor directory. Maybe we can spend a little bit on that, like what do you get when you get Odin? Because like I find vendor super useful, especially once we compare maybe Odin to Joy later on.
Yes, absolutely.
Which is so tell me a little bit what you get when you get Odin. What are the directory structures? Because I think there's like 3 categories. Right?
Yes. So we have a concept in the language called a library collection. This actually comes about because I was trying to solve a problem from C, where in C, you can include 2 different types of files. You can either include like with the speech marks, the quotes, whatever you want to call them, those specific things, and that would be like a local to that current file. The other one is with what's called the angle brackets or less than, greater than symbols. And those will do a look from an import path. Now, the problem is that import path is kind of globally defined, and it just finds the first one, which means it's like, oh, so I can't say exactly where to look. It's kind of just like a random list it's looking from, and then eventually says, well, you found the first one, that'll be it, which is worrying at the same time, but it's why it's a bit like I try not to use the angle brackets when possible. Some people love it, but it's like it has its own other issues. So in Odin, we had this concept of library collection. You just name a directory effectively, like by name, and then you can reference that and then literally use that as the base to then import from. Because import strings in Odin are just directories, so it's just a path to the directory. So in Odin, we have 3 that come by default. There's the base. So this is effectively the library that is required for all targets and implementations for Odin. So different compilers, different targets, whatever. In general, that's what it's for. We have the core library. So this is for effectively something that the official compiler obviously supplies, and any hypothetical one in the future may provide a different one, but usually they'll probably provide the same, I'm guessing. But this has a lot of built-in functionality that especially I thought that most people kind of want for most projects. So like, for instance, we've got, again, according to the operating system, we've got a lot of mathematical stuff, including like linear algebra stuff in there as well. So great for making games. We've got a lot more memory stuff. So again, your allocators, virtual memory, stuff like that. We've got a lot of like parsers for like JSON or JSON, INI, XML, all those stuff that's built in there for you. So it's all useful to know. There's all the stuff for reflection, for printing, for concurrency reasons, threading, all that stuff. So it's all like the core stuff you would actually use in many applications. Now, the thing you were talking about is the vendor library collection. Now, this one is a collection of third-party libraries that we kind of officially support. Now, when I'm making an application a lot, I kind of just want things that I just want to start an application. I don't have to worry about like, okay, I'm going to download this dependency, this thing here and there, and just get it up and running. When I'm like, why can't we just bundle that with the compiler straight away? So that's kind of what I've done. It originally just started off with things like OpenGL, and then added like SDL, and it's got so many packages. Like I just read the entire list. We have Box2D, we have GLTF. These again already game related. Common Marks. This is for like a Markdown library. So again, something you may want to do. We have Metal, like the Metal things for Mac and Darwin in general. We have the DirectX library, so Direct3D11, Direct3D12, the compiler and such. We have eNet, which is a great like little protocol and stuff based on UDP, so you can have some nice features. We have Font Stash. We have GGPO, which is a game general game. I always forget what it stands for, but yeah, for games. We've got GLFW. We've got Lua. We've got MicroUI, Mini Audio, Nano VG, OpenGL, Port MIDI, Raylib, STL, and all the other variants of like STL Image, Mixer, Net, and TTF. But they have some of the STB libraries bound, like EasyFont, Image, RectPack, TrueType, Vorbis, Vulkan, WebGPU, and Zlib.
Yeah.
And there's probably a few I'm missing as well, but that's just the ones I'm seeing publicly listed.
Yeah. And this is
so
great.
Again, it's great. You can just start using them, make an application, make a game. Great. I don't even have to download anything else. And that could just be for a prototype. It doesn't have to be for the final thing. Yeah. But it is just to get there.
Yeah, this is extraordinary because like in modern languages and often high-level languages, JavaScript, or like Node.js, right? Python, Java, things like that. You get a package manager. So the problem is solved in this way that if you want to use a library, you have a package manager that will download the library. In Java, you have a third party, but it's still like kind of like a core thing. And here you're against package managers. I think you have a very interesting take. I love it. But we can dive into this later.
Absolutely.
But because you ship with all the code that is very often used, like the libraries that are very often used, you don't have the problem like C or C++ people have, that they start a project, it's just C++, and now like, okay, how this library is being built, because I need to understand what it's like statically linked, is it dynamically linked, like how do I compile the library from sources? Maybe they already have pre-built binaries, maybe they don't, so I need to figure it out on my own. And here you can like download Odin, get Raylib, and off you go. Like this is great. And I'll probably keep mentioning this because like Jai is a programming language that Jonathan Blow is working on.
Yes.
And it is quite similar to Odin, but there are a couple of differences, and this is one of it. Like if I'm coming from a let's say higher level languages like JavaScript, like Python, into this world, to me, the understanding of each library, how is it being compiled, and how to create bindings for this library to Jai now from like C, it's like such a high bar of entry. And you pretty much like downgraded this, like brought this down to 0. Like,
okay,
it's just like, it's like, here you go, use Raylib.
Yeah, but it came from like, I've got a lot of experience using Python, and part of using Python is that its standard library, its core library is batteries included, right? Yes, they make people use pip to using like pip install, do whatever. And I know many people who don't make the distinction between Python the language and Python as the ecosystem. So they think, oh, Python, that comes with SciTools and NumPy and all that, like, even though they're third party. They think that's just part of the language. And that's fine. I mean, they're wrong, but it's fine to understand it that way, because they just do. They think of the language as the tool rather than separate, because it's only us C programmers who are so used to knowing all the distinctions because we hit them daily. Like, oh, C is the language. We also have different compilers. We'll have different libraries. We have different things. Nothing comes bundled together. So we already know where all these distinctions are. So everyone else is just spoilt because everything else is bundled together. So the thing was, I think that's a great thing. So which is why I've tried to make the Odin core library as rich as possible, as well as having the vendor stuff, which we don't have part of core. I think certain things in core won't exist either. Like, for instance, we won't probably have our own, how do I put it, like window management thing in core. But if we did have our own custom one written in pure Odin, like to replace SDL or GLFW or Rail or whatever, then we'd put it in vendor. Even though it's like first party, it's still like, we're going to put it in vendor because it's very much like, well, not every platform is going to support this really that we support. But also, it is kind of in that area. Like, look, this is the vendor libraries we have, be it third party or first party. You can just then use them to make your prototypes or even full applications. It's, again, I wanted that batteries included. You just be able to download Odin and get going. You don't have to, and I'll go like, oh God, where do I have to go now to download this? Or where do I have to read to do this? And the edit. It's like, I just want one thing, download it. I'm a simple man. Like, I'm done. That's it.
Great. How do you deal with like versioning for these packages, upgrades and stuff like that? There's so many
Slowly.
libraries. Like who is in charge of this? Like community, like authors, like have you managed to like
Mm.
convince Raylib author to actually update this for Odin, or how does it
No,
work?
I am the person who updates the Raylib packages
Okay.
myself. Some of the vendor ones are updated by other people, but a lot of them in there are also kind of, they don't need updating. For instance, like OpenGL.
Yeah.
OpenGL's getting no more versions
Oh
now
yeah, yeah.
instantly.
You're
So
done with
that's
that
great.
one.
We've written it once, we never have to touch it again. But certain things will need updating every so often. Like we have Vulkan, but I wrote a bindings generator from Vulkan in a Python script that just pulls the header files from the internet and then effectively parses it with again, it's a bit of a bodge, but using regexes. And the reason you think, oh, C is not parsable with regexes, is like, I know, but the Vulkan headers are regular enough that you can do it, and it works. And that's how we do it. So that's kind of and then we have to update the script because Vulkan, the Kronos effectively keeps changing their own consistency. So we've got a script to update that as well. But that's fine. That's the kind of thing. So we have different people on the core Odin team who update some of the packages. Some of them it's from me, and some of it's from other people.
Okay. I was told, or I've seen this comments, that Odin is like game dev skewed, and you keep mentioning
Okay.
it's like general purpose.
Yes.
How would you address this? Like, are there features for game dev? Like when you were listing packages for a vendor, I would say like I would estimate like 50% of them are very common in the game dev world, right? So it's like
Yes.
is just by the virtue of being low level language, it's already, let's say, somehow in the game dev mind, or how is it?
Partially. So clearly, I do making games myself, but there's nothing. How do I put this? There's nothing. I've got a really way of phrasing this. When people ask, "Oh, a language is built for games," that doesn't really mean anything, actually, as a statement, because it's like, okay, what's that mean? And then when you actually pin them down on it, when you find out, games are just one of the most general purpose domains you've got, and they really are one of the most general purpose. You will be doing basic systems programming. You may do some games, like when you do physics. You'll be doing networking. You'll be doing mathematics. You'll be doing a bunch of different domains that all bunched together. So you kind of have to be general purpose. Now, there's two aspects why people think probably Odin is game oriented, and they're not going to be wrong because it isn't technically a wrong statement to say. It's just that to me, it's quite funny when it's only for games, and I'm thinking that games are a lot broader than you think. Then in that regard, so like one of them is going to be like the vendor libraries. Yes, we have a lot of things in there for games. Like again, we've got the STL and GLFW, all of the graphics libraries as well, which again, not just for games. People use the right APIs for other graphical applications. Not everything has to be a game. We also do have like things Box 2D, which is 2D physics, which is again used by a lot of games and such. So there's a lot of stuff that in the vendor libraries which are specifically for games. The second one is we have features in the language which come from mainly dealing with a lot of graphics. So we have array programming built into Odin. This is one of those things I added to Odin, which was very pragmatic in the sense that I went, look, in C++ and many other languages, what do people actually use for operator overloading? And it turns out that from my empirical research, there was like two camps that you're kind of using it for. One of them is to add like functionality to data structures. Like again, in C++, you'd be adding an array type or a string type or a hash map. And you wanted to add, like, say, operator loading to access those elements and such. So that's the main reason many people use it. The second one is for mathematics. A lot of people want to do vector arithmetic or matrices or quaternions or such. So for me in Odin, I was very pragmatic. I went, I don't want operator overloading. That is a hell I do not want to get into. I've seen so much bad stuff with operator overloading, which is like, yeah, no, thank you. Just no. So I thought, okay, let's take the pragmatic thing. The data structure side already done in Odin. We just have those data types built in. We have arrays, slices, dynamic arrays, strings, even a hash map built into the actual language itself. So there's the syntax level done. So the other side was mathematics. And then I thought, okay, let's deal with the mathematics side. So the first thing was, I'll just make fixed length arrays, just work together. You can add them element wise or multiply them element wise and do that way. Now that works quite really well. It also has benefits because that's kind of how the hardware works nowadays with, again, SIMD, which is single instruction, multiple data. So that most of the time maps extremely well to the actual hardware. Now we do have a SIMD data type as well built into Odin, which is specifically for SIMD to say, no, this must be this way, or emulated still with SIMD, but may not be the exact one you were saying. Then we have built-in matrices in the language.
Yeah,
only small ones.
That's cool.
Currently up to 16 elements is all that we're supporting. We could go larger. It's not like it's only just a artificial limit in the compiler. But that's one of those things like, oh, why have you added this? It's like for games. It's like, well, no, 4x4 matrices are used a lot again in physics as well, right? We live in a 3-dimensional world, so 4x4 matrices works brilliantly.
Yeah.
And then you also have like quaternions and complex numbers built in as well. Again, complex numbers people use all the time if you're using like electronics and such, or any kind of physics and related. And then quaternions, again, great for 3-dimensional stuff, representing orientations. So again, these are all useful for games, but that's because games are like usually dealing with 3D geometry. Yeah. And it's like, well, why have you added these? Well, because they're extremely useful. So I've just added the things that people find useful directly in the language and be done with it.
Yeah, yeah. That's great. Like in C++, there's no linear algebra, like in terms of vectors and matrices in the standard. So you end up dealing with like whatever library you are using, and then you want to call a function from a different library, and like you figure out what was the layout in between so that you can cast it. Ideally not allocate another like a batch of memory, but just like remap the memory. It's like such a mess. And this is like, once you provide this, like, yeah, you kind of like ticked all the use cases that people were using the operator overloading. So you don't need to do it on your own.
Yeah, it's
really.
Not all of them, but I think beyond that, this is my personal view now, clearly, I think usually a lot of that's just a bit more crazy in a certain sense. Or they'll honestly, that individual should probably just write domain specific language. Like honestly, just have a little language you've written yourself and then transpiles to, I say C++ or whatever it is instead, because you'll have much better semantics and it'd just be easier to deal with. But that's kind of what I know. That's why people want it. They'll want like their own heavily like abstracted algebras that they want to make operators work with, and it's just very much that's going to be an absolute pain to read, especially with the limited operator set that C++ has and many other languages. So some languages I know, like I think it's Swift, allows custom operators as well. Like you can define your own operators.
Oh yeah.
Which is already insane in my opinion.
Scala as well. You can have like a colon,
that is
colon,
actually
something.
insane. Like that is something I'm like, no, that also complicates how the language has to be designed as well, which is not everything you should actually want, in my opinion, but whatever.
Yeah, Casey Muratori mentioned that like operator overloading was the one thing that he's using from C++, but this kind of makes sense if you're using, or let's say using like a C style C++ and you don't have data structures. So it's like you kind of want to at some point like replace all those like function calls with like vectors and stuff with operators. But
that's true. That's what I do in the Odin compiler. So when I wrote Odin originally, it was just a C compiler. I wrote it in C. Then I went to C++, back to C, and then back to C++ again. So clearly my style is very C-like. I was able to do this. But the reason why I went back to C++, even in then, I'm like, I thought it said C++. You prefer C over C++? And then it says, I do. However, the thing that always kept bringing me back was I wanted proper array types with bounds checking.
Yeah.
And I wanted a type safe hash map. Like, as silly as that sounds, those two things, one of them requires operator overloading and one required a very minimal use of templates.
Yeah. Okay. Can you tell me a little bit more about how would one go about making their own language? Just you've written a couple, and now Odin is quite famous. How would you start? How would you tell anybody to start? You mentioned like, oh, if you want custom operators, do your own language. How would I do that? Where I would start?
The first thing is kind of just the traditional route, understanding what a compiler does at the end of the day. So the first thing is the steps you do is you have something called tokenization or lexing, or there's many different terms. So that first thing is you learn how to read some text from a file or wherever, and then split it into these things called tokens. So these are keywords, your operators, identifiers, whatever, just get split up. And now you've got this big array, or a token stream in general is what it will be. And the next thing is to learn about parsing. Now, one thing I would just recommend anyone to do is just learn recursive descent parsing. That's it. Don't even bother. There's also probably prat parsing if you want to do fancy things with operators, so you can have like a based on like a table of the precedence, and then it doesn't finally. But that's really easy. Like you'll learn how to do that. It's just a for loop with an if check, effectively. But like seriously, just learn some recursive descent parsing. I don't know some great resources. Most resources I recommend, again, Niklaus Wiert's Algorithms plus Data Structures equals Programs book. This is not in print anymore, but you'll find a PDF online. In fact, I think there's probably a free PDF on the late Niklaus Wiert's website. Should be able to download from. And especially with compiler construction as well, which is another one he's done. Most of this is, again, recursive descent, which means you just recursively go through data structures, literally parse this pattern and recurse, found another pattern, keep doing this. Because that's how grammars are structured. Most things, or pretty much, are always recursive. There are, of course, issues, but it's still one of the easiest deals to stay with. And once you've done all the syntax size, this is your tokenization and your parsing, then you go on to your type checking. Now, the type checking, again, is not difficult. Most of this isn't difficult. It's just more of you learn the steps, you learn the process, and go start. Then eventually, the other one is going from now your type-checked code, whatever the syntax is, and also whatever representation this is in, and then lowering that down to machine code, right? Or just some other language, in fact, instead. Now, I highly recommend people do not use LLVM. LLVM is the bane of my existence, and I do not recommend it to anybody at all. That is from massive experience. If you're going to learn how to do things, do it from scratch. Learn how to, let's say, lower down to C, or lower down to actual assembly or machine code directly. It's not actually difficult. The difficult bit is producing optimized code.
Oh, yeah. Okay.
But lowering to anything, that's actually a hell of a lot simpler than you realize. And by doing so, you may even learn more about your computer as well. Like you'll learn actually, I need to learn assembly now. Like, this is how the computer's actually doing things. It's like, yeah, pretty much. But it's one of those where it's nice to learn. I also say that most people should need to learn how to do parsing in general. If you cannot make a parser for, like, say, JSON, go learn to do that now. And I don't mean like in a bit, like just learn it now. So it's a really useful technique because a lot of people don't understand parsing. They'll always default to like regex or something. And it's like, learn a bit of tokenizing and parsing, and you'll have something that's a lot more robust than regex, something that's faster in many ways as well. And you'll also be able to produce better error messages as well for your code. So it's kind of it's not just like it failed. Why did it fail? It just did.
Go figure it out.
Go figure it out. Just more of when you're writing a parser, you can actually correctly put errors. It has context as you're parsing. You're like, this is why it failed, and it went to this place here on this line and this column, so on and so forth. And it's a much better way of doing things. So that's how you can make a compiler. Again, there's some good resources out there. Fortunately, I don't know them because, again, the stuff I learned from is probably weird, or in that sense. But there's certain things I wouldn't recommend the Dragon book at all. Many people recommend that, but I do not recommend that because it's just it's opaque.
Okay.
There's probably much better resources out there.
Can you clarify something for me? You mentioned not to use LLVM, but like just for let's say the toy language you're making, right?
Mm-hmm.
Then try to learn it from scratch. But if you're serious about the language,
don't use LLVM even then.
Oh, really? Why?
Yes.
Why is that?
I regret that I used LLVM from the start now. So LLVM sounds like an enticing thing when you first see it, because it's like, oh, wow, an optimizing backend. I don't have to write that myself, right?
Yeah.
And it sounds like, they've done all the work for me. The short answer is no, they haven't. Yes, they've got all these optimization passes, but LLVM is an absolute mess. It is a buggy mess. It is not even really an API. They keep breaking things every single version. Versions come out every 6 months. You'll spend most of your time trying to fix LLVM, then you'll get the benefits out of. Now, if you say, it's really hard to make an optimizing backend, and I'm like, yes, I know it is. But it's not that. It's more of you could always have your own backend first, and then you could, if you really, really wanted, still not suggesting it, you could then have an LLVM backend as an extra option. But I'd recommend that you write your code base, not dependent on LVM, but depend just generically, and then start like, oh, you'll start seeing the patterns of how your code works. And also, you can also learn about some of the work of optimizing backends. A good friend of mine, he's working on a new backend compiler stuff in general, which we'll be using. He calls it Tilda or TB or Tilda backend. There's loads of different names he calls it, but this is what he's been developing, and it's based on the work of Cliff Click. Now, Cliff Click is a compiler engineer and designer, and he is absolute genius, really. So he's effectively like, there's loads of papers. My friend of mine, he's actually just implementing what he's done. He's met him in person, he spoke to him, all this stuff, and that's really good. So if you want to learn how to do stuff, you can. And the approach he's doing is called Sea of Nodes. So if you want to search it up, Cliff Click, Sea of Nodes, you can see all that sort of stuff.
C like
So you can then
letter C?
sea as in like
Okay, like a water.
the ocean sea.
Okay.
Because it's a sea of nodes, like that's kind of the
Okay.
idea of this optimization approach.
Okay.
Then you can implement it yourself, and you'll be state of the art as well in that regard.
Okay. Okay.
And you think, oh, it's going to be complicated. You can just learn how to do it as well.
I had the impression that LLVM when it was out, like it was incredible and like
Yes.
helped a lot for the optimization.
Oh yeah, indeed it did. I'm not how to put this, not criticizing any of the optimization passes in LLVM per se. I'm just saying that as a thing itself, it's a mess.
Yeah, I think it's now like a lot of people are working on it and doing crazy stuff at the same time, and like keeping up with like updating LLVM, it's a mess. I think so.
Yes.
But okay. And
It's a 20-year-old, over 20 years old, that project is. It was Chris Latner's PhD project, from what I understood, that got bought out by Apple. And clearly from there, it's kind of gone a little bit crazy.
Yeah.
And again, I understand that. I kind of forgive Chris Latner for that, because again, it was never really meant to be the intended thing. It just went that way. It's just one of those real big things. It's where like I have loads of complaints with it, and people say, what about the alternatives? And I'm like, the alternatives is do something custom, which is a lot of work, actually. I'm not saying it isn't. But it's more of a, when you're making a language, don't assume you're going to make it needs to be that great first. Literally, if you want to even optimize a backend, compile to C and then pass that C optimization to the C compiler, then let it do the optimization. Yeah, if you really need that.
Yeah. Oh, why like, so I see this like LLVM started, was really good, and then people were starting doing like all sorts of weird things at the same time, a lot. And it's like, what if you just didn't? Would it be better if you just stopped? Like, this is more philosophically in terms of like,
that's a good question.
Why adding this stuff? Like, I don't even know what is being added to LLVM, so it's like a very like a newbie talk at this point.
It's just usually it's to support more platforms, different like architectures and such. Sometimes it's just add new features to add better optimization passes. Sometimes it's just they're changing stuff to fix the mistakes of the past as well. Like one of them, I can't remember which version it was, but I think it's LLVM 14. I think I might be wrong, where they got rid of their typed pointers in their type system. So LLVM has this weird type system in it, which is was originally meant to mimic C, but it's all over the place. But they had these type pointers, and eventually they realized this is actually a pain. It causes problems. I won't get into details as to why, but short answer is they tried to just we have a generic pointer type now, which is not typed. And the only time you use the typed pointers is for when you're doing like load and store operations in that regard. So you're loading of this data type. And that's pretty much it. That's a much better way of doing things, because they can infer what the type of that pointer is from context and its usage. And that's it's much easier. It's just also much better for code generation as well if you don't have typed pointers. In the back end stuff I'm talking about, obviously, not the actual high level languages that people use. Type pointers are great, absolutely great. But in the back end, you don't need them. They're just addresses. So you can infer the types from their usage, and it's a much better way of implementing things. Again, there's loads of things like that which will break code and break the code bases and such. So you have to deal with them, put them, literally have edge cases so you can pretend everything's typed, but then it's not really in the back end and such, if that makes any sense.
Okay. Thanks for the LLVM lesson.
There you go.
Can you tell me a little bit more about the history of Odin? Like,
sure.
8 years now in the making. So, like, if you look back and you see how it evolved, like what happened and what were the, let's say, key points that like actually made this from a language that you started to do probably out of like frustration and things like that to actually a language that is now being used professionally at companies.
Yeah. So as I said, it started 8 years ago out of frustration of C, even trying to make C and C++ in general. And even when I realized I couldn't even make my own C compiler with improvements and realizing that wasn't actually going to work. So originally when I started, it was going to start out as a Pascal clone. So I even had begin end blocks and everything like that. So it was kind of, that's where I started. And then eventually I went, no, I'm going to go for C because like, as much as I love Pascal, I'd rather just have the curly braces than begin and end.
This was the
kind of
deciding.
thing.
This was the deciding factor.
Yeah, pretty much. And then eventually I got there about 3 months into it. I kind of went, this is pretty fleshed out. There's a lot there. And I went, actually, this might be a good thing to have. So I kept kind of going along with it after 3 months. And then after a little while, I'd say another, 2018, 2019, I had a lot of friends were starting to use it properly. And then a friend of mine started using it at his new company that he co-founded, which is called JangaFX, which is now the one I work at. And he was using it there because when he was speaking with his co-founder, he says, and co-founders asked, we're going to use C++. And he went, can we use anything but C++, please? We don't like it. And he says, I've got my friend Bill. He's made Odin. So can we just try and use that instead? And
he convinced co-founders to base the company.
His own he was the co-founder, but yeah, he's co-founder, yeah.
But like to build the company on a language that his friend built.
Yes.
The balls of this man. Like, wow.
I know, but he did that. And then eventually I came to work for the company a little bit later with my friends. And then it was kind of more of a... So I've now been working at JangaFX now. It'll be nearly 5 years now, which is amazing to think of. But it's a wonderful company to work for. But again, we're using Odin for everything. Now, Odin's not the only company that uses... Sorry, JangaFX is not the only company that uses Odin. On a website, there's Chia, which is effectively they do for statistical models and such, for model-based driven behavior as such. There's a few other companies, again, there's some game devs that use it obviously to make their own games. There's some application stuff. There's people who do profiling stuff. There's like I know probably over a dozen companies that use Odin. And it's like over a dozen. And there's probably a hell of a lot more that just I don't know about as well. It's just kind of the terrifying thing, but also surreal thing. Now, again, I want to say terrifying. It's not because like, Odin's unstable or anything. Like Odin's pretty stable, but it's still at the same time. It's more of this thing I started 8 years ago, and I'll be honest with you, when I started it, I was heavily drunk as well, and I live streamed it on Twitch. This is the kind of part of the story, but it's kind of more of that kind of drunken stupor led to this now nearly 9 year long, 8.5 year career, which is. Wow.
I've seen your streams with like a bottle of beer, a glass of beer, or like some cheese and stuff. It's usually it's like what the fuck is happening?
So be very careful. Most of these streams, I'm usually just overacting on top, obviously, because it's a stream. So I'm not like drunk, really heavily drunk or anything like that. And I'll just have like a glass of beer that I've brewed myself because I run a brewery as well.
Nice.
And I also usually have like cheese and crackers or something like that because I like cheese and crackers. Who doesn't like a bit of cheese?
Yeah.
So it's kind of more of a kind of trying to be sociable, kind of just overemphasizing the English stereotype a little bit on purpose as a joke. But it's more of a like that's how entertaining streams are on like Twitch and such. But yeah, that's kind of the thing. I'm trying to be very personal, trying to do like, look, I'm just here with me in my office, kind of thing. And that's how it works.
The company JangaFX was founded and started to use Odin. You at some point ended up working there as an employee, which is also very interesting. And but what have you done on the side of Odin Lang? Throughout like these 5 years, is it like picked up on its own, or you were doing some sort of marketing?
So I'm still kind of the core developer, but again, there's loads more now than just me. Look, thank goodness, the bus factor's not 1 anymore. It's probably around about 5, maybe a little bit more, maybe like 2 extra, maybe 6 if you class like 2 halves of 2 other people, if you know what I mean. But it's kind of one of those loads of people, different developers on it. So I still work on like bug fixes and such. But over those years, again, there's nearly 5 years working at JangaFX, I was fixing bugs in the compiler, adding features as we needed them. Because again, when you're working for a company who uses it daily, and it's not just you programming with it, it's like an actual full-on team, you start finding the issues with the language and you go, oh, that needs fixing, or that needs to be modified, or we need to add this new thing, or add some warnings, add some errors, add some more extra tooling to help us as a company out. And of course, they're all public, so all those things, because anyone can use Odin, everyone else benefits from it as well. Now, I tried, because I'm very much I'll say no to most things as well. Most people who will hear me suggest things, and I'll just go no, or never happening, or whatever. And some people may get frustrated by that, but it's very much like, you suggest something because you think it's cool, but you've not thought it through at all. And I can know it's because I'm like, and you also not checked to see if someone's asked that suggestion before. And it's like, that's probably been asked a dozen times before, if not hundreds. And it's like, I have to say no, because it's like, look, I know what you're trying to do. Here's another way of doing the thing with different constructs, features, whatever, even just maybe a library, and then just do that.
What are the most asked for features?
Sometimes people ask for methods, and I'm like, this is a procedural language meant to be
Hell no.
I'm not adding methods. No, and again, to be honest with you, I'm not against methods as a construct either. I'm just not adding them to Odin. Sometimes we also we haven't, to the point now we've got memes of it. People trying to make Odin a functional language, and I'm like, just stop trying to do that, please. It's not going to work.
Okay.
Like, this is a procedural language, man. It's very unabashed procedural. Try and make it functional doesn't work, because again, it doesn't really have Odin doesn't have like the type system to be a functional language. It doesn't really work. So you get all those issues and such. But again, there's probably a few more as well. It's just, I just have to say no a lot.
Okay. So I understand that, like, over these, like, let's say 5 years, people started to pick up Odin and also contribute to Odin. And this is what happened. Like, this is after 5 years.
Very organically, yes.
Okay.
I've not done virtually any marketing at all for the language.
Okay.
My marketing has been like podcasts like yourself.
Nice.
Or just Twitter. I don't really do anything else. And it's for my own detriment, really. But at the same time, it's very much like, well, I don't want to, and this is going to sound weird, I don't want to hype up Odin, because Odin's not really a hypeable language in that sense. Like, it's not flashy. It doesn't have killer features and all that lot. It's extremely pragmatic to a T, to the point it's like, this is going to help you solve your problems, and you'll forget about you're even using the language anymore. You're just solving your problems.
Yeah.
Which is not something which is easy to convey to someone. Which is why when I say on the main website, I say the joy of programming. And it's like, people go like, well, aren't other languages trying to be joyful? And the answer is, actually, no, most of them aren't. Like, when I say joy, I mean literally, I want to forget about the language. I want to program and have enjoyment from the programming itself.
I think like this no marketing style kind of approach is also heavily influencing the people that flock to Odin.
Yes.
And they kind of have this mindset of like, can please language get out of my way when I'm programming? So like, I think it's kind of like perpetual.
It is very good. It's the organic thing. It's not very hyped, and you get everybody trying to be like, oh, how do I do this quickly? Do this thing? Or can I do the fanciest thing? It's like, you do kind of seem to attract the more pragmatic-minded people who just want to get on with some programming.
Yeah. How does the core developer team look like now? Like, how many people? How?
Actual core developer team, it could probably about a dozen people. But actual like big people in there is probably going to, as I said, about 5 or 6 people.
Okay.
They all work on different things. Some bits are on the compiler, some bits of the core library. Sometimes it's tooling. Sometimes it's even documentation. And we all kind of just work on it at our own time. Pretty much every single one of us, including myself, really are volunteers. Yeah. Even though I work at JangaFX, I do work on the compiler sometimes at the company, but it's not my main job. I do programming for a living, not compiler work. So it's kind of that's kind of thing. So I do even outside of JangaFX hours, I do work on Odin as well as kind of volunteering there.
Okay. How, so I am following the Jai development, so the Jonathan Blow language. It's also has a lot of, like, it was born out of the same reasons, but mostly not like a C, but more C++ frustration. But the Jai language ended up being something of a modern version of C. It is now in closed beta, and I was wondering, like, so the Jai or Jonathan Blow strategy was to like have some people started to use that, but not like release it in public. How have you approached this? Like, when did you decide to like release it? Was it like open from the beginning? Have you had some issues because it was open? Like, how does this impact it?
So just let's talk about the thing. So I released kind of Odin about a month after development because again it was just a favor and just a little bit of a toy. I didn't realize like, oh good God, this code is awful. I'm not going to show it yet. But then I just kind of put it on GitHub open. Wasn't thinking much to it. Just more like, hey, this is what I'm working on kind of thing,
Okay.
which is all open source projects. And unfortunately, by the way, that's not necessarily a good thing. I wasn't trying to make a product that I was expecting other people to use. It was just for myself really. And then some of my friends started using it, and then clearly from there. Now, there are loads of problems with being open source, like loads. I'm actually not a big proponent of open source software in general because of many of these issues. So when Jonathan Blow is doing with his language, he's not making it open source. It's a closed beta. And honestly, that's not a bad approach to doing things because then you don't get all of the random features. You don't get all the random people asking for random features. You don't have to maintain any of the bad issues that people post, not just also the good ones. You don't have to literally review all these random PRs because this will sound weird, but when people post PRs, in a sense, it's kind of a bit rude. I'll be very careful when I say this, right? It's like saying this person's done loads of time, spent loads of time on this, and they expect that you, as like the open source maintainer, is going to take your time to review this, and also not just time to review it, but also actually, let's say review it with actually executing the code, checking everything else of this, and that takes a lot of time because and that sounds like well, that's not rude. That's what open source is, and it's like how do I put it? The thing is, most PRs are bad because most code by most people, including myself, is bad, right? So when you have to say no, this is not good, the person sometimes gets upset as well, and it's like this is not an insult you directly. I'm like, it's just not meeting the quality that we require because this isn't literally going to be used by loads of people. So then we're going to like sometimes it's also like the PR may be good, but it's like it needs some polishing. But then it's like you know what? I could write the same thing myself quicker than it takes me to literally write down what needs to be
Yeah.
changed.
Yeah.
So it's kind of one of those where the open source model has loads of bad incentives to it, which are not really going to be solved. And again, sometimes the closed source model is better as well because it's very much you have a lot more control as well. Like if it's closed source, it's closed source. You own everything as well. But it also has the problem is where you can't just have people help do these PRs. It's kind of like double-edged sword in both senses. So when Jonathan Blows wanted it to, and he's keeping it closed source, and you know he does want to keep it, he does want to open it eventually. I am like, I completely understand it, and I don't think he's doing anything bad with his language. It is a good way to approach things. I think the beta's gotten really big now. Apparently, I've never used the language myself. I have no intention of using it either because clearly it's not the language for me. But it's very much like some people criticize him for it. I'm like, I don't think you guys realize how much open source. Like if I'm having problems with open source, imagine someone as famous as Jonathan Blow. As soon as he did that, oh my God, he'd have to employ loads of people to then support this open source project, which is not going to be generating any money.
Yeah. Yeah.
Yeah.
So how much time daily do you spend on like or weekly, right? How much time weekly would you spend on the Odin open source reviewing PRs, responding and implementing things you want to implement, all sorts of things related to
It
Odin?
could be anywhere from, I don't know, 10 hours to 30 hours a week.
On top of your daily job.
Yes.
Okay.
I know that's a bit insane at times, but it is very much it's a part-time job. Like it's half, like I want to say 10 to 15, I'm saying like probably averaging around about 15 to 20 hours. So that's literally another half a job on top.
Part-time
And
job,
I don't get paid for
but
that
doesn't
really.
pay. Yeah.
No, and people say, you got some donations. I'm like, we don't have enough to pay someone minimum wage yet. So especially trying to pay someone who's actually a skilled engineer. And I mean, just an engineer, not a software developer, a software engineer.
Oh, yeah.
That's going to be another thing.
Okay. Let's talk about JangaFX. I've seen
Absolutely.
a couple of like products and visualizations and they are stunning. And
Yes.
visual effects in general are like this, one of the most arcane parts of things. Like you can kind of get your head around like how you can do things like animation or like rendering after
Mm.
you start this, and then you have like a visual effect. It like lasts 0.3 seconds. There's like all sorts of things happen you didn't even realize. Like, to me, it's crazy. Can you tell me a little bit more how the company operates? What do you do
Yeah,
there? Things like that.
absolutely. So, as stuff we do, we develop many things for the visual effects industry, obviously, and also for game developers and artists in general. So the very first project we ever released, which was before I actually started, was called something called Vector AGEM, which is make Vector 8 fields. We don't do that anymore. But that was kind of the first one. That was written in C++ as well. It wasn't even Odin. So the first project that was written in Odin was EmberGen. So EmberGen is a real-time volumetric fluid simulator that simulates fire, smoke, and explosions. And we mainly for the games, movies, film studios, TV studios, that kind of thing. But mostly we're oriented at games.
Let's break it down. Real
Yeah,
time. So
it's real time.
it's like, so for people that are maybe not realizing this, if you're like rendering a movie, like a cartoon movie, you can do it like a frame by frame separately and then put it in cinema. If you're making a
Correct.
game, it needs to be real time. So if you want to hit 60 FPS, you have like 15 milliseconds per second, 15 milliseconds per frame to actually do all your calculations. And if you stop, if you don't do that in this rigid framework, it breaks down.
Correct.
So this is the real time. Volumetric, now you need to do the definition.
Right. So volumetric. If anyone's played Minecraft, which I think probably half of the world has at this point,
Yeah.
that's a world built of cubes, voxels, we'd call them, right? That's a volumetric thing, right? So that's the thing, is you're thinking in these volumetric pixels. That's where the word voxel comes from. So EmberGen is no kind of different in that how that is functioning. To a certain extent, it's like it's dealing with these volumetric pixels in 3D space, where each pixel has multiple different values associated with it. It might be how much fuel is in there, how much is the density, the velocities, all that sort of things. Just how general basic fluid mechanics works and such. So all those kind of parameters that you need. Again, I'm trying to simplify it down a little bit here. And that's kind of how we store all stuff. So it's all three-dimensional rendering. So it's not just like two-dimensional. We're doing completely three-dimensional, volumetric. So that's what I mean. And we're doing all of that on the GPU as well, because the work that we do is perfect for the GPU for its optimization stuff. Now, to be very clear, we do not use Odin on the GPU. We use Odin on the CPU side. So Odin is for everything else. It's for the actual the graphics, and so literally the UI, all of the maintaining everything that interacts with the GPU, but not the GPU itself. So all the resource management, timeline stuff, everything you could probably name that's probably an application impossible.
And then
so that's kind of what we're utilizing there. So that's how we get it real time, because we know like, hey, this is what the hardware can do. We'll optimize for the hardware.
Yeah. And so real time, volumetric, and then fluid simulations. Just to mention, it's like very difficult thing in physics to properly simulate it, and then to do this in real time, it's like another level, because like these computations are just difficult to compute at all with precision, and then you need like all sorts of hacks to actually do this in the time you have, right?
Yeah, but it's not even, it still has to be physically accurate for the most part, but it's not going to be extremely accurate in that sense, because you've only got a certain level of precision, and you want it in real time, because the whole point we do in real time is to have instant feedback for artists. So the artist he can look at the scene he's doing, design it as does, literally tweak things as he needs, and he'll instantly see what's happening.
Okay.
So it's not like a minor thing here and there, if that makes any sense. It is literally a massive like boost. People sometimes how to put this, the competition, a lot of their stuff would literally take days, if not weeks, to render.
Yeah.
And we're doing it real time, if not near real time.
Yeah.
And it may not be, we're near as high quality, but we're not as high quality because we won't be able to be doing this as big in some regards. But if the artist has a quicker iteration time, he can make it tweak it to look as good as he needs in a quicker time, much like orders of magnitude faster, then he'd have to wait. I'm like, okay, doing this. Okay, we'll wait for this now. Put it onto a server farm somewhere else rather than his local machine.
Yeah. So how does Embergen look like in terms of product? Like, what would be the Embergen thing?
So could you rephrase that?
So what I'm asking is like, you say that Embergen is one of the products
Yes.
from JangaFX. Is
Yes.
this like an editor when I can like tweak things and see how things happen, or is this like a
Yes.
script? Like
Yes.
what?
So in the application itself, you have a viewport, you have a node graph, you'll have the parameters you can tweak, and they'll also have a timeline as well on the bottom. So because it's animated and such, you can put things on the put keyframes and such to animate, so you can then do what you need to do with the actual simulation. So there is like again a 3D viewport to see your simulation and such. The node graph, so you can set how things flowing through in things like, I've got this emitter with a shape that goes into our physics like solver, which goes into the renderer, which then you may also export. This exports into like an image, like a flipbook, or multiple image series, or like a VDB, which is a volumetric database file format. That's what it's called. And then all those different things throughout the flows of the pipeline in a sense. And then you got all the parameters on each node that you may be able to tweak. Again, if it's the shape of the thing, it could be the size, its radius, its thing. It could be that if you're talking about the smoke or the fire it's generating, you talk about the combustion levels. How does those things operate and map them all together in such a very nice and user-friendly way? And that's the whole point. It's just a graphical thing that you can show, and again, real time. I know that sounds like may not seem important, but if you like, it is really useful for an artist. Like an artist wants instant gratification because as an artist, you want to see what you're doing. You don't have to wait literal hours to see what's happened.
Yeah. I've seen the Weatherman with Hurricane.
Yes, we
was
supply them.
So fun.
Many of them are Imogen.
It was so fun. There's a guy walking, and there's like literally like hurricane just like 2 meters
Yes.
away. There's a thing flying in front of his face, and he's like speaking to the microphone. Super cool. What do you do there exactly? Do you have a specific thing, or?
I'm kind of a generalist in many ways, and always have been. So when I first got onto the team at JangaFX, the very first thing I did there was to create our file format.
Okay.
Before, I think it was a JSON file they were exporting to. So I didn't, again, at the time, the original file format we used, to be honest with you, it's not very good at all. But it's because it was we didn't know what we needed initially, that I made it so generic that I thought, okay, we might need to be able to do this in the future. But that was the first thing. Then eventually I went on to do some improve the rendering for the UI. Because again, I thought, you know what, we can do the entire UI in one draw call. Literally the entire UI is one draw call. So then it's done in now 150 microseconds. So not microseconds, microseconds, yeah. So literally we don't even have to worry about the UI getting in the way of everything else we need to simulate. It turns out it's just a bandwidth problem. If you upload everything all at once and then do everything else on the GPU, it's a lot quicker than if you were just trying to do everything separately, because bandwidth and sending draw calls to the GPU is slow. Eventually then start working things on like Imogen and such, fix things out. Then when it came to the other products we have LiquidGem and GeoGen, and we have 2 unnamed products we're now working on. One of them I am now working about 30% of the time spending my work on one of these new projects. I'm not going to say what it is, but it's oriented for game developers. That's all I'm going to say. So that'd be great in that regard. Okay. But that's kind of what I work on from day to day. I'm working on things like many of our products, many bug fixes. A lot of the time it is just bug fixes I'm doing, which doesn't sound like, it's only bug fixes. I'm like, that's a lot. Like some people, like you'll be fixing bugs most of your time in most jobs anyway, so it's not really any different there. But then sometimes you're adding new features to new products, and we've got 2 new projects. Again, not talking about what those are yet.
Okay.
But they're just we've got code names for them in that sense.
Okay.
Yeah.
Okay. How do you learn all this stuff? Things related to like compiler development. Language, making the language.
Yes.
Then like how languages work underneath, because it was like crucial for the Odin development and other things. Now like also GPU things, because like there's no way of not knowing GPUs when you want to do stuff like visual effects. Like it's not just like you can have zero idea about memory and write a Python script. You can't really write a shader without knowing GPU. Like it's not comparable. So how do you do that?
Slowly. You just start learning things, like just read up on it. That's how most people learn anything. To be very clear, my actual background is not programming necessarily. I'm a physicist. I used to be a quantum physicist before doing all this.
When did you start programming? Like how many
Technically, I
years
started
ago?
programming when I was about 10 or 11 years old,
Okay.
but it was always a hobby kind of thing. It wasn't just like a little bit of a hobby. And I was never planning on doing this ever as a full-time job,
Okay.
right? I went to go do my physics degrees, then go on to be a physicist as well. And then effectively I came back to programming in a weird sense. And it's kind of just how I fell into it all. It turned out for me, academia wasn't for me. I didn't enjoy it particularly. I enjoy physics still, because clearly what we do at JangaFX, everything's physics related.
Yeah.
Like we've got Imogen, which is again volumetric fluids. Then we have Liquigen, which is for liquids. Now I don't usually work on Liquigen. That's not one thing I work on much. But again, I still understand how liquids kind of work. We have Geogen, which again is for like I say, how do I put this? Terrain and such. But again, how terrain is generated is still a lot of physics, like how you've got fluvial erosion, you've got different things like that. It's just physics. And then that's kind of how it works on. So when you're saying, how do you learn all this? You just kind of start reading things you're interested in and then try and give a go at it. You will fail a lot. I think that's one thing people forget. You will fail a lot, so do not be afraid to fail.
Do you read books? Where do you get the knowledge from?
I read a lot of books from random sources. It's always very much like, what would you recommend? I'm like, I don't know what to recommend to people half the time.
Yeah, yeah,
There's
yeah.
one book I always have on my desk pretty much at all times, which is Hacker's Delight.
Oh yeah.
It's the second edition of it, and it's always good because there's sometimes the odd operation I need to come like, oh, I know there's some way to do this. Like, okay, what is it? And then I go, oh, it's in this book, or I can, oh, it's not in the book, but I can derive it from the book, kind of thing. And it's always a nice little thing to have side by side for you. That's one little thing for me, at least. But otherwise, you just read. Just keep reading as much as you can on anything you can, pretty much. If you want to learn about GPUs, start reading about that. If you want to learn about compilers, start reading about that. And read from multiple sources, not just one.
Yeah. Yeah, now it's like with ChatGPT and things like that. It's so easy to ask there a question and you don't ever know whether this is like a suffice. Like this whether this answer is like sufficient. Like it's tricky.
My view on ChatGPT, and do you mind me swearing just slightly?
Of course.
All these AI things, ML stuff in general, they are literally taught to be bullshitting engines.
Yeah.
Right? They are trained to give an answer that sounds good, but doesn't actually mean it is correct. It just sounds correct.
Yeah.
Right? So, and that isn't the same as actually knowing the thing. This is underselling what they are actually. They're more than this, but like they're kind of like word prediction things. They don't actually know anything. They don't understand anything. I'm very careful with that. They know loads of things. They know then do this how they connect things together, how they can predict things. So they can usually give you sometimes correct answers, but it doesn't understand that it's correct or not. All it knows is this has been trained to give something that sounds correct.
Yeah.
Right? And if you're not using that with that in mind, you will produce nonsense. Right? And I never use these tools myself. For the moment, I don't get any use out of them. I've tried them slightly, and once I was trying to say, hey, could you give me this program? Could you then please vectorize this now for me? And it did actually a pretty good job with a few mistakes. But I knew what I was looking at. And I went, okay, this is pretty damn good. I'm like, okay, it's made a mistake here and here, so I can tweak that.
Yeah.
But at the same time, it was like, if you didn't know it made a mistake, it's going to have loads of issues. And again, be careful with the tool. Just treat if you're going to use it, know its problems. And if you don't know its problems, don't use it. Seriously, do not use it.
Yeah.
It's one of those.
You're pretty restrictive with the tool set you're using, though, because like you're also against package managers and LSPs. So
I'm not against LSPs at all on like principle. It was just more of I found I was more productive without them.
Okay.
Which has actually surprised me as well, by the way.
Okay.
That's not. I'm not package managers. I'm against them for loads of reasons, which I've discussed elsewhere. But like LSPs, I've discussed about disliking them. is not that I dislike them as an idea. I used to think they were great ideas. And then I just said, okay, I'm going to stop using them. Like I wasn't using LSPs, I was using an IDs. I was like using IntelliSense in Visual Studio and such, right? Which is, I would say, a lot better than most LSPs in general. I stopped using it, and then actually it was a bit horrible for the first like week or two. I will say that it was a bad experience. And then after that, I was finding like I'm back to my previous level of productivity, and then got even more productive because I was starting to learn the code base I was working in.
Yeah.
And I was having to actually read the documentation, and I started to learn why things they were the way they were, rather than just looking for autocomplete all the time. And that surprised me, though I went, oh, I'm more productive without it. Now, if you're more productive with it, great. That is a wonderful thing.
Yeah.
But
this exercise, even though like it hurts, I've done this for Jai, the mentioned language. There is no LSP there, so I'm just like stuck with writing the language itself, and like I learned this so well compared to all the LSP style helpers. It's like it's wild that you can like get rid of this tool that is supposed to help you, and like you don't even know what you're losing.
That's the thing. You don't know. This is the thing. A lot of people don't like question themselves, like saying, "Does this actually help me make me more productive?" And just try that a day. Literally, try something different. As silly as this sounds, try a different text editor. Try a different LSP. Or try not even using them. Try reading the documentation directly rather than try and rely on like all that stuff. It's like you'll start realizing, oh, these tools that I thought were better for me turn out they're not.
I think we're very close to the one question that is quite popular now. What is the state of software today, and what are the problems?
The state of software today, poor. This is the best way of putting it.
Why? Or maybe like what
there's loads of reasons why. So when I say it's poor, it's like okay, and maybe you think, oh no, software just needs to be this bad, right? It needs to be this slow. This needs to be whatever. There might be people make arguments, and first thing you can just look at like, okay, take the current piece of software you have. I say it's Microsoft Word, for goodness sake. Yeah. Okay. I used to use until very recently Microsoft Word from 2007.
Okay.
Right. And I had that until like last year when I went, oh God, I've kind of had to be forced to update to use it now because I was trying to open more modern files and they weren't opening in my older version. So I was like, okay, I'm going to have to get a new version. So you take that from there and compare it to today. The 2007 version opens instantly.
Yeah.
Right? It has pretty much all the same functionality than the new one. It has a better UI, in fact. It's all these things where it's like, wait, this is a better product. And nowadays, you're now being forced to spend a lot more money on it as well. And I don't do the subscription version. I just buy the product outright because you can do that for Microsoft Office. Still, luckily. But it's like, okay, so the thing from like 2007, which is what, 17 years ago at the time of recording?
Yeah.
What? Or you take any other piece of software you've got. Some software today will be better. There is honestly better software what's back then. But now the stuff today is just more of a, how do I phrase it? It can be better. And people say, no, it just has to be this way. Like, no, it doesn't. Okay, look at games. Games have to be real time. They have to be run fast because otherwise no one's going to play them. And games do a hell of a lot more complicated things than the vast majority of your software out there.
Oh, yeah.
They do. Some things, like we say, a web browser, oh, they're bad. And like, now the problem they're bad is for loads of reasons, actually. Like, but a lot of it is just a lot of technical debt. I remember reading an article once where, like, the search bar in Google Chrome was doing thousands of allocations.
10,000
per keystroke. Was it per keystroke?
Yes.
Which is like, why is there any allocations happening in the first place? There might be. I'm not saying there shouldn't be, but does there need to be that many? And you think, oh, people say it doesn't matter. It's not going to be slower. I'm like, but now I think that is a death by 1,000 cuts. Things are going to be awful. And things don't have to be this way. I think it's just a lot of people don't care about what they're doing. And there's also like, sometimes it's not their fault. Like they're in the companies and the companies are incentivizing them to make stuff quickly rather than quality. And also there's, how do I put this? Some programmers think, oh, it doesn't matter, the hardware will keep up with this. Hardware's cheap. We'll just put more hardware at it. And it's like, yes, but do you know how fast your hardware currently is? And most programmers will go, no. I'm like, your program you've written could probably be 10,000 times faster with very little effort as well. But you could do that, but you're just not even bothering with that effort.
Yeah.
And it's like, okay, I'm not saying that everyone needs to be using like C or Odin or whatever to make these applications. You could apply these principles to whatever language you're using, or even toolchain in general, and still get better quality software. It's just that most people don't seem to give a damn.
Yeah. I would mention here like computerenhance.com, which is a Casey
Yes.
Muratori course, which I love and like taught me
Yeah.
a lot about these things that I was never taught, like either
Yeah, I
university or
have
like,
learned a lot from Casey over the years. Again, 10 years
yeah,
ago was Handmade Hero,
yeah.
and that literally changed my life. That did. Literally.
In what
Uh,
way?
I wouldn't have made Odin in the first place. I wouldn't have made any of this. Like, I wouldn't have got to where I am without Handmade Hero, without Casey just doing that thing. Because there was like a few things that did me with it. It was very much like he brought me back to going like, you know what, the way you initially started learning to program, that's actually better than the way you've been taught to do everything else. Right. So I was learning all this modern, at the time I was in my modern C++ phase. I never went through like an OOP phase, like object-oriented programming phase. I went through the modern C++ phase where I was using all the move semantics everywhere, all the templates everywhere, making it all using the correct everything like that. So I was writing effectively like 5 times more code than I actually needed. But I thought it was a good idea because I thought, oh, the people I thought were the experts were doing this. So they must have some wisdom. And then Casey's thing came along, and I thought even just the trailer alone, if everyone's never seen the Handmade Hero trailer, please watch it. It's very endearing. It's lovely. But then also the first, I don't know, 40 episodes of Handmade Hero, the very first 4 you will learn a ton from them. Like if you've never, so much you'll learn from them. And it's like, oh, I can actually program in this kind of style and it works. It's simpler. I'm writing less code. It's more productive. And also this guy knows what he's talking about.
Yeah.
And he's also telling me how to learn it as well.
Yeah.
It's wonderful. So again, his computer enhanced courses now that he's doing nowadays, over it's computerenhanced.com.
Computerenhance.com. It's called
Yeah, they are
Performance Aware Programming
Yeah.
Series. Yeah.
Yeah, and they're getting very wonderful talks. And I know many people who subscribe to him and use them and find them brilliant. So yeah, I would always thank Casey for everything. So, and especially what he's doing now.
It's so interesting. He told me that like he had his email address for like 2 weeks on the website and then he like took
Yes.
it down, and he's like 10 years after he's getting emails where like
Yes.
this course changed my mind, and it's free
Yeah.
on YouTube and it's still
Yeah.
like there. It's like it's so wild. And you have like programming books with like
Yeah.
design patterns. It's like Jesus Christ, and it costs like $100. It's so
Well,
weird.
it's not necessarily the price. Like for me, Handmade Hero is worth a hell of a lot more than he was charging for it. Like because you could pay for the source code at the
But
time.
Handmade here was like 0, right? Like this
I
is
know.
this
Like
is,
just if you watch the streams, it's 0. Yeah, and it's
Yeah.
like. And then you get, yeah, you're right. You get all these other books that cost a fortune, and they're not actually even good anyway. Like the design patterns. It's like, again, the problem with those books is more to do with they're telling you what the patterns are and to apply them first, rather than write code and then see the patterns that naturally emerge. Right, and that's it's the wrong way around, in my opinion. Like it's always when you write programs, you'll start to see these patterns that emerge. Not the other way around. Like, oh, these patterns, apply them. You must apply them everywhere. And it's like, but how do you know if they're even the right patterns to apply?
Yeah.
I'm not saying the patterns are bad. Just like, do you know they're the right ones to apply in the first place?
Yeah. During my university course, I had to, for example, make a project and use X amount of like number of like design patterns. Like it's
Okay.
like
I've got no formal education in programming, so it's like that.
It's like use 4 of them, and it's like don't matter what you do, just use 4. And it's like,
huh?
and this is the like it's just so
No,
weird.
that makes no
like,
sense to me.
Yeah, it's very interesting. Like so this is why I think like maybe Odin is also like popularity of this language is increasing, because there's more and more people that realize that like, look, this is like a modern language. It's simple. It doesn't have a lot of things that I'm used to, and people say it's nice. And then like for let's say for first 2-3 weeks, I don't know how to handle it. But if you push through this initial phase, you're like, oh, that's a way simpler thing to use for like than compared to all sorts of other things I've used before. So that's great. And there is an upcoming conference, Better Software Conference.
Yes.
Do you know what you're gonna speak about?
I have an idea that I know what I'm speaking about. I won't say it yet, obviously,
Okay.
because I've not
Okay.
finalized it, but I have an idea.
Okay.
And it's something, the reason I'll talk a bit very vaguely, but it's one of those things which I very rarely see talked about in general. And it's more to do with like, I think the reason why, I'll just be very careful, it's something related to physics. And you think,
Ooh.
why is that useful to anyone? But it's kind of like, no. If you're a physicist, you kind of get taught this. But if you're a programmer, you never get taught any of this because you don't have the mathematical skills for it yet. And
Okay.
it's kind of like you don't have that toolbox, which is there. And I'm not just being very vague on purpose.
Yeah.
I don't want because I might not. It might modify since what I'm going to be
Yeah.
talking
Yeah. Yeah.
about.
Yeah.
And it's just very much like, well, I came back from a physics background. I have a lot of mathematical background, obviously, and stuff, and that has helped me in a lot knowing how to do many other things. And programmers don't have that background. They usually don't even have. They'll have probably basic calculus at most, or algebra, maybe, or even just algebra. They may not even have calculus. And it's like, yeah, but a lot of the stuff you're doing, if you're making games, you are doing calculus. You didn't even realize it. Like anytime you see delta time,
Oh
well,
yeah.
that's integrating, right? But it's like most people don't understand how to do integration correctly, make sure things are stable or anything like that. It's kind of like, well, okay, but people just don't have the mathematical background. All the other one is matrices. Like many people use matrices a lot, again, in like graphics, and many of them don't understand what matrices are or like how to actually they work or different operations you can do. And it's just stuff like this, where if I said the word eigenvector to you, like most people go, what?
Yeah.
May go like self-vector, what's that mean?
Yeah.
And it's just more of a like, yeah, but it's just more of these things are very useful. And again, I'm not saying that programmers need to know more math. You don't need new math to get into programming, but more math you know, the better you will actually do things as well.
Yeah,
In
and it's
fact,
like
as well.
it's not about like whether you need it, it's like whether you want it, right? Like it's
Yeah.
the out there. Like
Knowing it in the first place. Yeah, it's a tool. If you don't know the tool
yeah.
exists, how can you utilize it?
Okay. That's awesome. There's Odin book now made by
Yes.
written by Karl Zelinsky. So
Yes.
congrats on making a language
Yes, I
that
know.
gets another author to spend so many
Yeah.
hours
That
to make
is
a book.
surreal.
And it's featured now in Godbolt.
Yes.
I need to check it out. I learned that it is, but I still don't know like the exact
Yeah.
things. So I need to. But congrats.
Thank you.
And you know where people can follow the work of Odin and you. Where can people get in touch?
The website in general for odinlang.org, the GitHub, which is again, just look for Odin Lang on GitHub. Or then there's me on social media in general, which would be on Twitter, would be at the Ginger Bill. And then other places like that as well. So it's kind of that's how you can follow me. And usually a good place to chat if you want to talk about Odin specifically is be on the Odin Discord. That one's where most things are most active. There is also an Odin forum for people who prefer forums.
Ooh, forum.
But
Okay.
yeah, we got a lot of people asking for that, so we had it not that long ago, and it got quite. Oh, wow! There's finally a forum. Thank you. I can now use it. 'Cause many people don't like Discord for some reason. I guess partially because searching in Discord's awful. But
Yeah.
one of the benefit about the Odin Discord is if you ask a question, you'll probably get an answer within a couple minutes, if not instantly.
Yeah.
And that's not an exaggeration. So it is one of those where maybe not do the search. I'm like, no, just ask the question, and then you'll probably get answered very helpfully by someone. Could be even me. So, yeah.
Great. Thank you so much for joining me for this discussion.
Yeah.
It was such an honor. Thank you so much.
Well, thank you very much anyway for having me on.
And good luck. Good luck in the future. Good luck on your upcoming talk at Better Software Con and
Yes.
everything that relates to Odin and JangaFX.
Yes, thank you very much, and thank you for having me on. I hope your game engineering podcast does well as well.
Thanks. Thank you so much for listening to this episode of the Game Engineering Podcast. Don't forget to subscribe on YouTube and follow on Spotify and other podcasting platforms. See you in the next episode.